Sanibonani guys, I hope you're all doing so well. Grade 10s and grade 11s plus grade 12s and even grade 9s are welcome in this video. But specifically for grade 10s now. We are in a new season, new year, new academic year. We start fresh and we're going to fight to win in our academics. So guys, today we're going to start a new term with algebraic expression. Under algebraic expression, we're going to talk about multiplication of algebraic expressions. Multiplication of algebraic expression. Okay, guys. Now, there are factors that you need to take into account. There are three factors that you're gonna use, or methods that you're gonna use to multiply out algebraic expressions. The first one is the law, the distributive law. The second one is going to be the product of two binomials. And the last one for today, we're going to talk about the product of a binomial and a trinomial. I'm going to explain them properly when we indulge more into questions. Let's start with the first one, the distributive law. Let me just write it down here. The distributive law. Now, in simple terms, to distribute is to take something from this side and distribute it or transfer it to the other side equally so. Which means you distribute something, you transfer something into something. I hope I'm clear on that one, guys. Now, what is an example of a distributive law? If you've got x, let me just say bracket a plus b, the question will say expand and simplify this question. X into a plus b. Remember, this is a product. Why? What is a product? Product is like multiplying. Product is like brackets, having brackets, and a term outside the bracket. So this term, which is x, it's a product of this bracket. I hope I'm clear on that one. Which means a product is like multiplication. These brackets, it means this thing, all of it it's a product, basically. All of it is a product, this thing. X into a plus b is a product. This x is going to be distributed equally into a and b, into this bracket, basically. Which means x, you're going to multiply. It's a product multiplication. This x is going to multiply this a, and the very same x again, equally, is going to multiply out the second term, which is b. Now, equal to, now the aim in algebraic expression is to expand and simplify out brackets. That's our aim in algebraic expression in most cases. So you must make sure that you simplify out brackets. You must make sure that you multiply out brackets in algebraic expression. Now, x times a, they are not like terms, okay? Therefore, it's going to be x a. Okay, guys, I multiplied x and a. I hope we are clear. Then plus, you've got plus in the middle, you bring it down, plus the very same x is going to multiply b. X and b are not like terms, therefore you bring them down together. If they're not like terms, you bring them down together. Therefore, this is your answer. You are done. There are no like terms here. It's x and a, x and b. They're not like terms, those two terms. Then the second principle that we want to talk about is the principle of the product. The product of two binomials. You guys, you said that the term product means brackets, couple multiplication of brackets, something to that part. Now, product of two. What are binomials? In grade 9, we learned about monomial, one term, binomial. Bi means two. Binomial, two terms. trinomial 3 times. Tri means 3 times. Now here talking about the product of two binomials. The brackets of two binomials, which means you're going to have two brackets, and each bracket is going to contain a binomial, two terms in it. For an example, if you've got A plus B, you're going to have two brackets, C plus D, which means product, or this is the product. All of it is a product of two binomials. Binomials are two terms. So we're going to have two brackets, and this is the first binomial and the second binomial. So you've got a bracket of two terms in each bracket. Yes. Now, remember, your aim in algebraic expression is to simplify out what? Brackets. That's your aim in algebraic expression. Now, how do you simplify the brackets in this case? There's this law, concept there, FOIL, FOIL. Foil, this is the concept that we use, a formula we can use, a principle we can use to simplify out a product of two binomials. Two binomials, remember, FOIL. F for first, O for outers, I for inners, L for lasts. Very important and simple, guys. Let me just explain now. And here our aim is to multiply. We are multiplying out algebraic expressions. We are multiplying here. We are multiplying literally. Yeah. Now, how to multiply here? Remember, first. F for first. First, what are you talking about? First, we are saying the first term in each bracket that you meet when you enter. Let me just say we enter into this bracket. Which term do we meet? When you enter into this bracket, it's A. It's A. We meet this term A. Which term do we meet when we enter into bracket? This second bracket is C. We meet C. A and C are going to multiply out themselves. That's how FOIL works. I hope you are clear. Then O for outers. Outers are those expressions that are out, basically that are on the side of the bracket, which means when you check, B and C are not out, they are inside, they are in, but A and D, A protects B and D protects C. A and D are exposed, are outside, are outsiders, or are outers. They are outside. Whenever you just enter into a house, you're going to meet A. Whenever you enter this house, this bracket, you're going to meet D. A and D are outers. Therefore, A and D, they are going to multiply out of themselves. It's going to be A and C, A and D. Then inners, I for inners, inner, those terms that are inner, that are inside. B and C are inside. I hope you can see. B and C are inside. B times C, because they are inside. Then the last one is last. We multiply out last terms. Last term on each bracket. A is the first term, B is the last term of the first bracket. C is the first term, D is the last term of the last bracket. B and D are going to multiply out themselves. Hurry. This is equal to A times C is AC. Plus, you bring down this positive. A times D, AD. Guys, we are done with A times C, we are done with first outers. We are going to inners and lasts. What are inners? B and C. So this positive sign, I bring it down here, plus B times C, BC. Then the last one is lasts. Last k b and d. The signs are the same. You bring it down. B times d is bd. Then you are done. You are done. That's how you use FOIL in an expression or in a product of two binomials. That's how you use FOIL as a principle. Ne? Now, let us do the last one. The last principle that you can, the last method you can use to multiply out algebraic expressions. The last principle, guys. The last principle. Before we do examples, ne? The last principle before we do examples. The last principle is of what? Is of the product. The product of a binomial and what? And a trinomial. The product of a binomial and a what? A trinomial. I think it's a binomial get two terms. For an example, if you've got x plus y, this is a binomial. Then the second part, I get it's a product. It means it will multiply again. Product of a binomial can a binomial then trinomial. Trinomial can say a plus b plus c. Then is a trinomial. Then expand and simplify here. Remember, our aim is to simplify out brackets here. Nothing more, nothing less. Hurry. Remember, we multiply out brackets here. Hurry. In 23 on our second example that you just removed here, you're going to do exactly the very same thing. X and y. X is going to multiply each and every term inside this bracket, and y is going to multiply out each and every term on the other bracket. Hurry. X is going to multiply a, x is going to multiply b, x is going to multiply c. Again, y is going to multiply a, y is going to multiply b, y is going to multiply c. Then you are done, literally. Guys, hurry. X times a, xa. X times b, here we bring down this positive, plus. X times b, xb. X times c, xc. Then you are done with x's. You're coming to y. I bring down this positive and here y. Positive here. You must check the sign, remember. Y times a to ya. I bring down this positive because positive times positive is positive. Y times b to yb. I check. I come to y times c. Positive times positive to positive. Therefore, y times c to yc. Then you are done with y's. Are there any like terms? No. Therefore, you are done with this example. I hope I'm clear on that one, guys. I hope I'm very much clear. Now, let us do examples. Okay? Let us do a few examples that might be examinable. Remember, here we're already preparing for first term exam. Here, we are preparing for first term examination and second term examination and fourth term examination. We are preparing for final examination here. So we are preparing for first term exams of mathematics grade 10, grade 9, grade 11. We are preparing for second term examinations, junior examinations, and we're preparing for December and September examinations. I hope you're not going to take everything that you are doing here granted. Example number 1. Expand and simplify. Expand and simplify. Example number 1. A. We've got the negative 3a bracket 3a cubed minus 6a squared plus a. What is expand and simplify? Expand and simplify. Now, very simple, eh? Yes, very, very simple, guys. Now, remember, go back to our start. Go back to where we started, and you're gonna see what this example is similar to the distributive law. Go back to your notes. We just wrote notes right now. Ne? Go back to your first principle of distributive law. Go back there. You check what this example is the same as that, is exactly like the distributive law. And this example was taken from an examination. Imagine from a question paper, but it's similar to what is in a textbook at some point. The distributive law, it says whatever that is outside the bracket must multiply out each and every term inside the bracket. That's the definition of a distributive law in mathematics, grade 10. Now, this negative 3a is going to multiply out each and every term inside the bracket. This negative 3a is going to multiply out 3a squared. This negative 3a is going to multiply out negative 6a squared. And lastly, this 3a, negative 3a is going to multiply out a. That's how it works, guys. Unfortunately, that's how it works. Hurry here, guys. Hurry. This equal to negative 3a times 3a cubed. For those ones, I want to take you step by step. Hurry. It's going to be negative 3a. And you guys, multiplied by 3a cubed. And I'm taking guys step by step. And yes, that is what I'm doing right now, step by step. Now, hurry. Second one, negative 3a times negative 6a squared. Hurry. And you should check the sign before you can do anything. Negative times negative. Positive, and therefore it's going to be positive here. And here, guys, it's going to be positive. And you're going to have 3a multiplied by 6a squared. Already you have multiplied the signs there. Even on our first term, yeah, negative 3a times 3a cubed. You could have said, if there's nothing in front of any term, in terms of the sign, it's positive. Next to 3a cubed, there's positive sign there. This negative times this positive is going to be negative. Negative times positive is going to be negative. Therefore, I can put in negative here and remove this one. I can do that. But it's still the same. Well, I hope you are clear on that one. So you start with the sign first. Hurry, the second one, the last one, the sign again. Negative times positive. This negative times this positive of a is negative. Therefore, inside the bracket, you've got 3a multiplied by a. I just want to simplify it for you guys. For you to understand, I need to simplify it first. Then I bring down this negative. I bring down this negative. Now, first step, you start with your bases. You start with your coefficients. The numbers. 3 and 3 in this case. 3 times 3, 9. You put 9 here. Then a and a are same bases. Remember, a and a are same bases. And we are multiplying. When you multiply same bases, you do what? You add exponents. A to the power 1. You're going to add those exponents. 3 and 1. This 1 and this 3 are exponents of a. A and a are like terms. You bring down your a. You bring down your a. Then 1 plus 3 is 4. I hope I'm clear. And you guys, please check it back. A and a are like terms. Therefore, 1 plus 3 is 4. I'm clear on that one. Then I bring down this positive. This one I bring down here. Then I come on my second bracket. 3 times 6 is 18. Plus 18. Then a and a are like terms. Here I bring down a. Okay. Therefore, when you multiply same bases, you do what? You add exponents. A and A are same bases. Therefore, you add what? Exponents. 1 plus 2. 1 plus 2, guy, 3. This 2 and this 1. This invisible 1 here, 3. Then you put in 3 here. Simple. You come to the last bracket, minus. You multiply out the numbers first. If there's nothing here, you have positive 1 invisible here. Next to A, you've got positive 1 here. Why, guys? Simple. Therefore, 3 times 1, 3. Then A are like terms. A and A are like terms. You drop down A. Then 1 plus 1. And same basis. When you multiply, you add what? Exponent. Then it's going to be 1 plus 1. 2. Therefore, you write 2 there. Are there any like terms? Are there any like terms there? Are there any like terms? Yes. In terms of the numbers. Because 3, go 18 on the part 9. So you can take out the common factor there. Common factor is going to be 3. Then the 8 we take out the lowest. We take out an A with the lowest exponent. Between A squared, A cubed, A to power 4. Which one has got the lowest exponent? Is A to power 2 here. Therefore, we take it outside the bracket, A squared. Label? That's how we do it, guys. Then, what you're going to do in this case, you're going to find the term. Yeah. This is my common factor. So you're going to say the first term, which is negative 9A to power 4. Negative 9A to power 4. Our first term divided by our common factor, which is 3A squared. Our first term divided by our common factor. You find the answer there. Negative 9 divided by 3 is negative 3. Then A and A are like terms. You bring down the like terms. Therefore, when you divide same bases, you do what? You subtract exponents. Therefore, 4 minus 2, give you 2. Bible. Then you're going to write it here, negative 3A squared. You come again to the second term. Second term, give positive 18 A to power 3 divided by our common factor. Hurry. 18 divided by 3 is 6. We have the same basis here. A and A are same basis. You drop down the A. Then when the same bases are there, when you divide same bases, you do what? You subtract exponent. Therefore, 3 minus 2, you get 1. Therefore, I'm going to drop down plus 6A here. Then the last but not least is the last term, which is negative 3A squared. Negative 3A squared. Negative 3A squared divided by our common factor. Negative 3 divided by negative 3 is negative 1 here. Then A and A are like terms, therefore you drop down A. Then when you divide same bases, you do what? You subtract exponents. Therefore, 2 minus 2 is 0 here. You write 0 here. But whatever any term or any number to power 0 is 1 here. Come on, negative 1 multiplied by A to power 0. 1. Negative 1 times 1 is negative 1, the answer there. It's going to be negative 1, the answer. Then you close the bracket. You are done. If you can multiply out these brackets, it's going to bring back to this part. If you can multiply out them, 3A squared times negative 3A squared. So guys, number 2, you are back with it. Expand and simplify. Remember, go back to our notes wherein we talked about the product of a binomial and a trinomial. Binomial and a trinomial. This is a product of a binomial and a trinomial. It's simple. How do you simplify such product? The first term of our binomial is going to multiply out 3 terms of a trinomial. I have 2x times x squared here. 2x again times negative 3x. 2x again times positive 1. There are many ways to simplify this one, but this is one of the simplest ways to simplify it out. Then this 4 again is going to multiply each and every term inside the trinomial. Hurry. 4 times x squared, 4 times negative 3x, 4 times again 1. Oh boy, guys, hurry. That's how you do it. Do it yourself. Pause the video and do it yourself. Hurry. Remember the sign. Positive times positive. You positive and here. You put positive there. It's okay. Sharp. You can leave it like that. 2x times x squared. 2x multiplied by x squared. Thank you, guys. Then 2x times negative 3x. Thank you. Positive times negative is negative. Thank you, guys. Then 2x multiplied by 3x. Label? Are we clear? Yes. Then you come to the last one. Positive times positive. The positive, thank you. Then 4 times 1 is... No, guys, no. We come to the last one, yeah, 2x and 1. Positive times positive is positive, yeah. Then 2x times 1. Oh, that's 2x times 1 is 2x, yeah. There's no negotiation for now, it's 2x. There's nothing sophisticated there. And yeah, guys. Are we clear on that one? Are we clear, guys? Then we come to the next term, which is 4. 4 times x squared, here. Positive times positive is positive, here. 4 times x squared, here. 4x squared. Label, simple. We come to the second term in the trinomial, which is negative 3x. 4 times negative 3x, here. Positive times negative is negative. 4 times 3x, here. 4 times 3x. Label, simple. Then the last one, k positive times positive, k positive, here. 4 times 1, k positive 4. But this is the last one. Sorry for doing this, guys. I don't have a space here, but I hope you can see it. Okay. Then you simplify out. Okay, hurry. What's it? 1 invisible. 2 times 1 is 2. X are like terms. X and x are like terms. Therefore, when you multiply out same basis, you do what? You add exponents. Come on, someone. For x here, you bring x down. You're gonna say 1 plus 2. Okay, 3. That's how we do it. I bring down this negative. I'm gonna multiply this bracket out. 2 times 3 is 6. Then same basis, x and x, you subtract. Same basis. When you multiply, you do what? You add exponents. So I'm gonna have 1 plus 1, okay, this squared, the 2, okay, guys. Then I drop down this positive, okay. You've got 2x here, you bring down 2x. Then you've got 4x squared, you bring down 4x squared, and matata. You come to the next bracket, which is you bring down this negative, okay. 4 times 3 is 12. Then this x has no like term inside this bracket, okay. Therefore you bring down that x like in that way. Then plus 4. The last term is plus 4. This is our constant. Then when you arrive at this step, you look out for common factors. Couple like terms, actually, not common factors, like terms. Let's check for like terms. 4x squared and negative 6x squared are like terms. And because of what? Because of this x squared. Okay? Now let us bring down those ones that do not have like terms. Arena x cubed, and therefore I'm gonna bring down this 2x cubed. Then squared. Again, if you've got like terms, just like negative 6x squared, and this one, positive 4x squared, you do what? You add them. You add those coefficients of x squared. 4 and negative 6, you add them. Hurry. Negative 6 plus 4, okay? You put it on the calculator. Negative 6 plus 4, minus 2, minus 2. You bring down what? X squared. You don't do anything about x squared. You bring it down. If you add like terms, you bring down then to the x squared, couple of the variables when you add the like terms. You don't do anything about variables. When you come to x, are there any like terms? Yes. Negative 12x and positive 2x are like terms. X and x. And here x to power 1 here. And here I've got x to power 1. These are like terms, guys. If you've got like terms, therefore you add the coefficients. Among 2, positive 2 minus 12. Okay? Minus 10. And here, then x and x are like terms. You bring down the x. Then the last term is our 4, which is positive 4. Has no like terms. You bring it down. Then you are done. That's how you do it. I hope I'm clear on that one. Then let's do another example, guys. Another example. Number C. Oh, guys, there's a lot of examples here, but we are doing it, guys. We are doing it. We are preparing for examination. Here. Preparing for examination, guys. Then the next example. The next example is as follows. The next example is as follows. See, you've got 2x into 3x minus 4y, and here minus 7x squared, 7x squared minus 2xy. I think let me just write it properly downwards here so you can see it properly. Number C here, 2x into 3x minus 4y minus bracket x 7x squared minus 2xy. Simple. Remember we learned about distributive law. Distributive law. We learned about it. Therefore, we're going to apply distributive law in this case for each bracket. Because of what? We've got an exponent, a term outside the bracket. So this term, which is 2x, is going to multiply itself inside each term inside this bracket. So we're going to have 2x times 3x. You're going to have 2x again times negative 4x. 4y, I mean, yes. Hurry. So you're going to have 2x times 3x, 2x times negative 4y. That's how we do it. Hurry. The sign is our own. And you're going to positive here. Therefore, it's going to be positive. 2x times 3x, 2x multiplied by 3x. And you're about same signs. Positive, therefore it's positive. Then positive times negative, and you bring out this negative, you open a bracket. 2x times 4y, 2x multiplied by 4y. Then you close the bracket, you are done. Then here you've got minus. As long as you've got any sign between negative and positive outside a bracket, we've got an invisible negative 1 here. If you've got negative or positive in the middle of two brackets, it means we've got negative 1. And yeah, so this negative 1 is going to multiply out each term inside this bracket. Negative 1 times 7x squared, negative 1 times negative 2xy. Hurry. Negative 1 times 7x squared minus 7x squared. Okay? It's like that. Negative times negative is positive. Bible. Then 1 times 2xy is 2xy. I hope I'm clear on that one. This is equal to, so guys, as you are continuing here, now, hurry, guys. The second step, we are going to say 2 times 3 obviously 6. Again, same basis. When you multiply same basis, which is our basis, our x, we do what? We add exponent. 1 plus 1 plus 1 plus 1. You guys get 2. We're going to have 6x squared. Now, you drop down this negative here. Then we're going to have 2 times 4, 8. Then x and y, are they like terms? No. Therefore, we bring them down, both of them. 6, negative 8xy. I hope I'm clear on that one. Then negative 7x squared has no problems. You bring it down. Plus 2xy also has no problems. You bring it down. Okay, guys. Then you check for the like terms here. Now x squared is here, x squared is here. Then it means they are like terms, therefore you add them. You add their coefficients. You drop down x squared and add its coefficients. X squared. Then 6 minus 7, keep going, negative 1 here. Therefore I'm going to have negative. Yes, guys, so as you're continuing here, we've got x and y are like terms, therefore you add its coefficients. Which means you add the coefficients of what? xy. Negative 8 and 2. We add them. Negative 8 plus 2, okay? Negative 6 what? xy. Bible, guys. Then you are done. Now, the last thing that you might check is the what? Is the common factor. Common factor. Now, what's common between the first term and the second term? Which variable is present on my first term and my second term? X and x. Now, for x, we take out the x with the lowest exponent. Now, between this x to the power 1 and x to the power 2, which one is got the lowest exponent? X to the power 1. Therefore, I take out x like that outside the bracket. That's my common factor. Then now, I'm going to look out for the term that's going to sit here. How do you find that term? You say the first term, which is negative x squared, divided by my common factor, which is x. In this case, negative 1 divided by 1, negative 1. Then x and x are like terms. Therefore, we have got same basis. X and x the basis. They're the same. Therefore, if they're the same, when you divide, you do what? You subtract exponents. 2 minus 1. This one, x exponent. 2 minus 1 give 1. Therefore, I'm going to have negative x here. There's no need for you to put those ones there. It's unnecessary. Yes. Then the second one, we've got the second term, which is negative 6xy. Okay, guys. Now, negative 6 divided by 1, negative 6. Then, this x, and this x are the same in terms of the exponents. X to the power 1, x to the power 1. Therefore, they're going to cancel one another. They cancel one another. If they're the same, they cancel one another. It's 0 if they're the same. Then you're left with y. You're going to have negative 6y. This y, you bring it down, so you're going to have negative 6y. Then you are done with this one. You go to the next one. The last example for this work activity. The last example from previous question papers, obviously. Yeah, the last example is number D. Guys, so let me just change. The last one is 2x minus 3 over x, all to power 2. Now this one, it means we've got 2 outside the bracket. You're going to have 2 brackets basically. That is what it means. You're going to have 2 brackets of 2x minus 3 over x, close bracket, you open again, 2x minus 3 to the power x. We're gonna have two brackets of 2x minus 3 to the power x. Hope I'm clear on that one. Then we've got two binomials here. Remember FOIL and here. Do you still remember FOIL, guys? Two binomials. We're going to have, how do you remember, our aim here is to multiply out brackets. That's our aim. When they say expand and simplify, remove those brackets. We don't want to see those brackets in here. So I'm going to have 2x obviously times 2x in here. 2x again times negative 3 to power x in here. Then another one, I'm going to have negative 3 over x times 2x, negative 3 over x times negative 3 over x. We're going to multiply them out, those things, all of them. Hurry, the first one. Deciding the positive and positive here. 2x times 2x equal about 2x multiplied by 2x and here, guys. Our first bracket, then we are good. Positive times negative and here is negative. Right? Then this 2x times 3 over x and here. 2x multiplied by 3 over x. You close the bracket and here. You come to the second, this one, yeah, negative 3 over here. Here we are done with 2x. You multiply 2x with each and every term on the other bracket, not on each bracket, on the other bracket. And here we come to 3 over x. Hurry, negative, this negative times this positive is negative. And here bracket 3 over x times 2x, 3 over x multiplied by 2x. And here, guys. Then the last one is negative times negative, positive, and here positive. Therefore 3 over x times 3 over x, 3 over x multiplied by 3 over x. I don't have a space, guys, and hence I'm doing that. Hurry, we are not done. Then 2 times 2 you guys, you 4 here. X times x, I get when you multiply same basis, I get x is the same, x and x are the same. When you multiply same basis, do what? You add exponents. 1 plus 1 you guys get 2. When I have x to power 2, I add exponents to x. I drop down this negative. Then here you guys run another fraction. This 2x is the same as 2 over 1 here. And guys, and when you multiply these brackets, in this case, you multiply numerator by numerator, denominator by denominator. And here, come on, 2x times 3 is 6x. And here, then 1 times x again, x on the bottom. Am I clear? Yes. I bring down this negative. Then I have a fraction here again. This 2x is the same as over 1 here. Then numerator times numerator, numerator times denominator. This 3 times 2x is 6x. Then x times 1 is x. Are we clear, guys? Then I bring down this positive. So guys, then I come to the last bracket and here 3 times 3, I get giving you numerator times numerator, my denominator times my denominator here. 3 times 3 is 9 here, over x times x squared. Hope I'm clear on that one. Then here, guys, we have something interesting here. Over here in another fraction, and the bases are the same. X and here to power 1 to power 1. Therefore, this x cancels this x and here because they're the same in terms of the exponents. I think they're the same. And here, the same thing with this one, x to power 1, x to power 1. They're the same. They subtract one another. And here, then you are left with 4x squared. And here you are left with negative 6 minus 6. And here, negative 6 minus 6 minus 12 plus 9 over x squared. You are done with this example. We are done. Thank you very much, guys. Don't forget to subscribe, like, and share to your friends who might need this assistance from us. This is Vuzomuzo Tutorials. We do maths and science from grade 7 to grade 12. If you need assistance There are our numbers on our description portal here on our YouTube channel. Please don't forget to subscribe and follow us for more